I'm Dan Gibson, and welcome to another video in the series Navigation in the Qibla. In this video, we have, this is video number 5 in the series. We have some guests with us, 3 friends who have been emailing me over the past while. I ended video 4 saying that, there's different things need to be explored. I had presented what the Nabateans knew. And then my question was, what can we do with the knowledge that we've gained over what they knew about navigation using the stars and counting and so forth. Then I got emails from a number of people, and especially these 3 men, who had responded with some ideas and presented different things that came to their minds. And so I've asked them to appear on this video and to share some of their ideas, and we have not met each other. Other than just a minute ago. So we will hopefully be able to dialogue together and learn something from each other. So I'm going to first of all let them introduce themselves, and then we can go on and find out what each one has said. So just a little bit of introduction, maybe where you are or what made you interested. Let's start with Hughes, who is over in Paris. A little bit of introduction.
So hello, I'm Hughes Simpson. I'm French. I'm living in Paris. So excuse my English. I'm not a native speaker. I'm interested by this question because I've been puzzled for a long time by those questions. I've used to work in the Middle East, and I used to talk with my friends there, and had more questions than answers. And with the presentation of Petra, it seems that I got more answers than questions. So thank you.
Okay, Hughes. Oh, Mark, over to you then.
All right. I'm a retired Navy Lieutenant Commander. I'm here in New England. My name is Mark Estrella. I've been very fascinated with Mr. Gibson's presentations. I am a voracious student of history, and I just love what is being presented. And I had a theory, and I presented it, so here I am.
Okay. And you have navigated using the stars. You're experienced in that?
I am an experienced Navy navigator. I'm also, I've done Boy Scouting and stuff like that. Done many presentations, and some of the videos that have already been produced gave me some ideas on how I thought folks at that time would be doing the correct Qibla directions.
Great. So we'll keep that in mind, that you are our experienced navigator. Okay. I don't know if Hughes has you ever done any navigation using stars?
Yes, of course. I didn't say that I am an officer. I used to be officer on the Merchant Marine in the French Navy. Okay. So I know how to navigate with sextant and also with without a calculator.
Okay, great. And then over to Dale. Explain a little bit about who you are and why you're here.
My name is Dale Bourne. I'm a licensed professional electrical engineer. I live in Idaho, which is a desert environment, probably not as desolate as Saudi Arabia. My navigation background was in scouting and so forth. I was leadership in there, and we did a lot of orienteering, and so that was fun to do. I first became involved with this when several years ago, I simply was curious about how old the city of Mecca was, and I ran into all kinds of stuff on the internet where that turned out to be a controversy. And so when Dan's video came out, I was able to capture that and was fascinated by your suggestions. I have a real love for mathematics, but there are other ways of solving problems besides using equations. And so I'm intrigued to find out what everybody's solutions are. That would be interesting to me.
Great, thank you. Okay, Mark, let's start with you. And you've got, I think, a slide or two there, some pictures. Share with us the thoughts that came through your mind when you were dealing with this, thinking.
Okay, let me take a quick second to pull up my little presentation. Okay, can everybody see that?
Yep.
All right, there's a quick intro slide. There we go. So I went back to the basics. And what did they have at the time? They had lots of time on their hands. As your videos described, we had 2 hours in the evening and 2 hours in the morning after they set up camp. So I can envision that they had the knowledge and the directions already done, probably for several centuries, because these trade routes were very well known, but they were also trade secrets. So the caravan master had the knowledge for traveling back and forth. And then in the evenings, we had the rock sticks and the campfires. So I can envision the caravan master spending time each night with an apprentice or several, having them recite each turn, poem count, who they had to contact, the landmark guides and stuff like that. So by reviewing the trip around the campfire, they'd probably set down a few rocks, plot things out. Back in the military, we called this the rock drill. So this is the pre-briefing before execution. This way everybody saw it. Old movie, The Dirty Dozen. You saw them doing the rock drill with a little setup. But they would go through and reiterate everything over and over again, because all of this information was rote memorization.
Right.
So how they got this, so we go back for mathematics here. The angles of a triangle in building, and here I'm going into my carpenter's background. We would take a 3, 4, 5 triangle, and that way we can set the square of the building, get that 90-degree corner. And if we have the opportunity, we can expand that to ensure that the angle is better. So we get a 6, 8, 10 triangle. Notice that these are multiples. So as long as the ratio of the angles stay the same, everything will come out. So whether we make our trip 2 feet long or 200 feet long, the angles will be the same. So now, advanced math at the time was in existence, but the average person probably didn't have the knowledge to execute Pythagoras' theorem. But since they were builders, somebody's already done the math, and they probably knew that if they took 3 units, 4 units, they would end up with 5 units on the diagonal. So, and since the Nabateans were excellent builders, this would translate out to the caravan folks. So again, the keys to this in my mind is the knowledge of how the trip is done over land, the directions that are being taken, the poem counts, and then the local landmarks and guides. The local landmarks are set up, in my mind, as such that any error while walking, you would be taken out by getting close to the landmark and then correcting that small error. And then over time, errors left and right would equalize themselves out to come very close. And since the trade routes, when they started transferring over to water routes instead of overland routes, we ended up losing the ability to do this. And as you discussed in one of your other videos, when they set the mosque in Jerusalem, the caliph had to bring in an elder in order to set the correct direction. And that tells me how the mid-period mosques were not as accurate as the early periods of mosques, because the overland trade routes were becoming more sea routes. And then
sea routes, and also because they were moving into Roman territory, there were Roman milestones and Roman roads. You didn't need to navigate anymore.
exactly, exactly. Yes, sir. So what I did is I took a little screenshot of one of your pages there, and we'll do a quick trip from Petra to Damascus. So I can envision us at the campfire at night, campfire being Petra, and having the students or the apprentices walk out into the desert. One step for every poem, 2 steps for a longer poem, whatever keeps the ratios approximate. And they would pick out the stars and go toward that direction and continue that until they were 200, 400 meters in the distance away from the campfire. And then as they look back, that rum line, that straight rum line back to the campfire, they can see in their minds the rose line direction, which would be their direction of prayer, once they started praying in those directions sometime after the 5th, 6th century. So that's my presentation in a nutshell, sir. Any questions?
So I'll just ask you a question. So when the Quran, when Muhammad revealed it, or he's the one who said this, when he talked about you have now a Qibla, a direction of prayer, you don't think he was asking them to do something they didn't have the tools to do?
Correct.
Okay.
The travel and the mathematics has probably been in use in existence for quite some time by that time. As you said, these caravans have been trading for centuries by the time Muhammad came around.
Right.
So, yeah, I'm not trying to build anything into it. It's what the simple things that the folks, the nomads, would have already known how to do.
Right. Anybody else with a question or comment?
Let me get rid of this. There we go.
Okay, Dale, you want to take us maybe a little farther, or what you've been thinking through in this process?
I find that my ideas are very similar to Mark's. I would like to go a little bit more into detail how this could have been done, and without any mathematics or equations in particular. I'll get to my PowerPoint slide in a minute, but I just want to try and say, I think, Dan, in your book, you've given us the basic tools. You did a good job of reviewing what was available in terms of tools and techniques. And the 2 key things in your book is the idea of pacing rather than using time, and then also using the Arab compass. So the rum line are those off angles between north, south, east, and west. And I can't even pronounce the Arab names for them, so I'll just refer to them as rum lines.
Yep.
So the first concept I want to try and suggest is, no matter what path you're taking, you can reduce that path into straight line segments. When we're doing UAVs or something, we call these waypoints. And so I'm suggesting, when traveling through the desert and so forth, that the Arabs were very careful to walk in straight line segments and then turn from one rum line to another rum line. Now, if you've got an Arab compass with you, even during the day, you don't have to take time. If you lined it up at night and you've got a landmark and perhaps a mirror landmark to you, lined up 2 landmarks, you can tell that you're going to be right on that rum line as you travel. And so if you've got an Arab compass, you've got the angles with you. You're always at the center of that compass. And so you can determine paces is every time you hit the your right foot on the ground, steps, however you want to measure it. You can count those. You can use poetry. I hadn't thought of that, but on the internet they have things like ranger beads. They count beads. You can use green finger mounts. I used, just as an experiment, I counted every 10 paces. I used my fingers and I counted on fingers, and I was able to get up to 4,000. It's takes some concentration. You can get distracted, but it's possible to do. But even for fairly long or short lengths, what happens is as you go from one point to the next, the thing is you need to keep track of the distance between that line segment starting and end point. And the thing I'd like to suggest is that counting is one way of tracking distance, but there's another way of doing that, and you can do this easily, and this is why I call it my string theory. If you've got a cord, you tie a knot in the bottom, and let's say each finger represents 100 paces. That's 200 steps. If I go 400 paces, all I have to do is wrap my fingers around a cord, and that's 400 paces. If I want to go 800 paces, I can do double. If I want to go 1/8 of the width of the finger, I can mark it with my thumb, and if I've reached that point, then at the end of that straight line segment, I can tie a knot that will represent that distance. Just straighten it out, and I'm not very good at doing this with exact, but with practice you can get it to be exact. You just tie a knot in the line, and that represents an estimate of the number of steps that you took. It doesn't give you a number, it gives you a length of string. Okay? Now, if you go to the next segment along another run line, so you still know exactly where north, south, east, and west is, you've turned and made sure you're on one run line, you just make another segment between two knots. And you do that throughout the day. Now, I want to get to some issues about terrain later, but let's finish what we would do. Like Mark, at the end of the day, you get down by the campfire, and you can take two sighting sticks, find the North Star. So you can draw in the sand a north-south line between two sighting sticks, okay? So you have that. Now, using your arc, as you suggested in an earlier video, you can use a stick or a string, and you take these opposing arcs and you get an east-west line. So this is what I call a template. It's just a plus sign drawn in the sand, all right? Now, what I would do is I would take the first string length, place the first knot at the template where the cross of the north, south, east line is, and then take the string and align it with its run line distance out. That gives me a diagonal. At that point, I would take a sighting stick at the end of that run line, or that string, I should say, and I would place a sighting stick there. Then I would take, along the east-west line that's been drawn, another sighting stick, and I'd sight the North Star. This creates a rectangle, okay? And what it also does is it allows you to take another string from the center of the temple, the north-south line, out to the sighting stick that you used on the east-west line, and that gives you an estimate of the distance you traveled east or west that day. Now, you can do this for that line segment, and then you do this repeatedly, and you get it for the entire day, okay? Now, actually, you can do this for the north-south as well as you do it for the east-west. I suspect counting paces from north to south would actually be more accurate than sighting the North Star, just because it's really hard for I can't get an eighth of a finger very well. It's hard for me to do. But that's the key. Now, the problem that we run into, you can do this over a month's time on the string. If you have a red string for the east-west, you just tie knots for every day, and a blue string for north-south, and tie knots for every day. At the end, you can call your elder in. He's got this string, and you lay it out in your north-south, east-west direction, and you have the distance as the bird would fly in terms of steps, and the direction between your beginning point and your ending point. And that's just, if the estimate has stayed with you, it's not hard to do. Keeping track of the run line for every knot on your string during the day, not a hard thing to do. If you remember, Harry Lorraine had his link system. This is an ancient system, goes back to the Greeks. So this was well done. You could do it in your head, no problem. The issue that you may run into is terrain. If, for instance, you run into a situation where there's a gully and it really doesn't make sense to try and to stay on a run line and count paces and so forth, you can look across the gully and find a landmark. Now, I have a PowerPoint. I showed it with you. It's probably too busy. Let me do a simple exercise. If you take your hand like this, and put your thumb in the right hand, then your vertical hand there, you can just throw it there. Place a landmark in the line of travel right at that notch between your finger and your thumb. Okay? Now, you want to pick a second landmark somewhere along the length of your thumb. For ease, let's say it's halfway right at the notch. Okay? Now, that's your first sighting. Then just travel towards that first landmark until the second landmark appears at the end of your thumb. It will lengthen out and go from the middle of your thumb to the end of your thumb. When you've reached that point, you've counted your paces, you know you're halfway there. So you know the distance to the landmark you're heading towards. Now, if you want to do it for a fourth of length, where if your second landmark is 3/4 of the length of your thumb, then you know you've got to multiply it by 3, the paces that you took to the second sighting. That's easy enough to do. You don't even have to do this in your head. You can do it with the string. All you have to do is take whatever distance that you're paced between the two sightings, fold the string over to the same length. That would give you your distance if it's halfway. If you want it 3/4, you do it 3 times. And lo and behold, you got the distance from your second sighting to the landmark you're heading to. So if you reach a gully or something that really doesn't make sense to do, just pick a landmark out in front of you, estimate the distance with your string. You got it recorded already. Just hike to that point and you're there. So I think we can overcome the problems, practical problems of terrain, obstacles in the terrain, but we're using your Arab compass at all times. We're using your pacing at all times, and we really don't need anything else. And then I have some comments on how to do it over thousands of miles. So that's what I have.
Is there, okay, okay, let's see if anybody has any comments or questions. Then I want to come back to that, how do you do it over thousands of miles?
Yes.
Any comments or questions?
No, I thought that was great.
Okay. I've often wondered why the camel caravans went through the desert, sometimes a little longer route than going through the mountains. And I think this helps explain it, that they could actually navigate better in the desert. The deserts are mostly plains, sometimes with sand dunes that move around, but as long as you were standing on the plain, the flat gravel plain, when you did your sightings, you would be able to navigate through the desert, it sounds like, much better than if you went up through the mountains and down to somewhere else.
I did want to make a quick comment. Later in your book, you mentioned that you have these young Arabs going on pilgrimage, and they leave their army unit, they dash out into the desert, they're riding camels, so they're not pacing, right? And they've got to find a water hole in the middle of the desert without fail, or they die. From a mathematics point of view, you just need 4 pieces of information, 2 pairs. One, a landmark, and a run line associated with that landmark. And so they go south until they see that landmark, and they know the run line from their Arab compass, and then they go along that run line until they see a second landmark that they can identify, and its associated run line, and the X marks the spot. So anywhere in the plain of that desert, all you need is a landmark and an associated run line. 2 of those will give you any unique spot in that plain or desert. It's not the coordinate. It's not Cartesian coordinate systems, but it's going to be the same effect. So it really doesn't take a lot of information to even convey to somebody who hasn't been there before, for them to be able to find the watering hole. That's interesting.
Okay, thank you. Okay, Hughes, over to you. You've been thinking about this. What would you like to add to this?
First of all, I would say that the British mapped India with very similar techniques. So, I mean, it makes sense. They trained surveyors to walk the very same pace, in very same stride, so that they could count the distances. And then also they were doing triangulation. But it's the very same techniques, actually. So this proves that your methods work. They work. We don't have to demonstrate that it works because the British did it. And they mapped India very precisely. So makes sense.
Okay. Now, you were sharing with me what you thought might be able to be done maybe a little later on, but when this builder, in the videos, we use a builder who is building his stick and his pole, and he's marked out to find the east, west, north, south, the cardinal directions, and then he puts in the points of the Arab compass, and then you were explaining to me that he could continue on and perhaps add some more things to that bit of construction in order to determine the Qibla direction. Do you want to share some of that?
Yeah, actually, I've prepared a presentation.
Okay.
Before everything, I would like also to recall that the Nabateans were also navigators. They had trade posts in Italy, in the Mediterranean. So they knew how to navigate on the sea in the desert. So maybe since we are at least three of us seamen, it's good to tell. Yeah, so yesterday I was in the metro and I said, okay, the big issue for a navigator is time and how you can keep time. So, and we discussed with them many things in just to eliminate the solutions. You know, the hourglass was invented very late. So that's probably in the 14th century. And it was a few minutes. In the 24-hour hourglass was invented, I think it was in the 17th century. So it was late in time. The other issue is it's hard to measure time by looking at stars because your instruments are not precise enough. To measure time with the stars, you need a star as a reference in, let's say, a planet or the moon, and you need ephemeris. You need tables, so that you know the exact relative movements of all the celestial objects. And we know that the Arabs had those ephemeris during the 2nd century of Islam. I didn't find any reference for them to have those ephemeris sooner. So it means that they were not able to measure time by looking at stars. Before the invention of the chronometer by Mr. Harrison, the ships were having astronomers, and the astronomers were measuring time with the moon of Jupiter. But you need a telescope to measure. So in the telescope didn't exist in the 7th century. So and yesterday I said, okay, let me show you my presentation because I prepared something. I need to go back. Okay, share my screen. And okay, and slideshow. Okay, so okay, here I propose something that could have been possible if I had been in the shoes of the eras of this time. I could have used this technique. The issue is I didn't find anything in the literature that could mention this usage. So first of all, if you want to calculate the Rome line, you need to know the precise position of the two cities, where you are and the cities you want to measure the direction of. Measuring latitude is easy. Measuring the longitude it's pretty hard, and it took a lot of time to be able to measure time with a very good precision. And just as a reminder, if you do 4 seconds of error when you are on the equator, you make 1 nautical mile of error when you are on the equator. At Petra, latitude is 0.87 nautical mile. Oops. So the first thing is how to measure the latitude. I believe that the easiest way is to use the North Star. I will not enter into the details, but it's easy to make an astrolabe to measure the direction of the North Star in the 8 of the North Star. And when you have the 8, you do 90 degree minus the 8 of the star, and you have your latitude. So it's common. So this is pretty easy. It's achievable, and it can be if you build a big astrolabe, it can be very precise. So now, how did they measure time? We know that they had clepsydra, water clocks, but they are not transportable. The hourglass was invented many centuries later, and the hourglass is not precise enough. But for a long time, it has been the only way to keep the time, and it's also how the seamen were measuring the dead reckoning with hourglasses. And I said that to measure time with stars, you need very precise ephemeris, you need good telescopes and whatever. So I have another hypothesis of what I call the leaky sunbag. It's like an hourglass, but you have a big bag and you have a hole, and you measure the time for between 2 points by wetting the bag, and you can know how much time was elapsed from the time you left, let's say Petra, or in another in your destination, by just measuring the weight of your bag. And how do you measure time? Actually, you measure the time in reference with, let's say, Petra, with a point, with a meridian. And if my bag was weighing 24 pounds when I left, and if I've calibrated the leak to lose 2 pounds a day, then a difference of 1 ounce represents an hour. When I arrive at destination, let's say after 20 days of travel, in that case, and I have 4 pounds and 2 ounces left in my bag. So, I've probably done an error. Oh yes, I've done an error. Sorry about that. But the calculation should give you the difference of 1 ounce. It means that the difference between Petra and the point where you are is 1 ounce, which represents an error. What I didn't say, sorry, I went too fast, is you measure your weight when you leave Petra at noon, and then you open your bag, and when you arrive at destination, you plug the hole in the bag, and you measure your bag, and then what you get is the difference in time between noon in Petra and noon where you are. And from that difference, you can compute the pole angle. And the bigger your bag, the bigger the leak, the more precise is your leakage sun bag. So what do you need? Obviously, you need sundials in both cities. You need a way to measure the weight of your bag. You need a bag, and you need to fill your bag with sand. I just wanted to recall what a rhomb line is. In French, we call it loxodromie. It's a line that keeps the angle at every meridian you cross. So it's pretty complex, but you can have a very simple approximation that uses the difference in longitude and the difference in latitude, and those values can help you to get the angle of your rhomb line. You don't need to use complex tools. I'm sorry, I didn't have time today to finish that slide, but I wanted to show you very simple tools that allows you, when you know the difference in time between noon in Petra and noon at your destination, which gives you the pole angle. Very simple tool. You don't need something very complex. And you can compute the latitude, the direction of let's say Petra. So the question is, was it likely? Because I knew that you were proposing this keep it simple, stupid solution. I just wanted to propose something different.
Okay, go ahead.
The difference, the technique was achievable. And the necessary knowledge was there. The issue is, I didn't found any reference to this leaky sandbag technique. So I believe that the step counting and triangulation technique that you presented is more pertinent. And I have questions for you, or for everybody. Was the Mizbaha, which counts 99 beads, used to count steps? Did the camels set the pace? Because I've been told that they have the stride of the same length. And was the Mecca pigeon breed especially developed for finding the direction of Mecca? And I'm finished.
Okay. We're gonna have to. I should have written down those questions. I know one was the last one was pig.
Yeah, but I can send you
The first one was the Mizbaha.
The Mizbaha, yeah.
Yeah, and the second one was.
The second one was the stride of the camel.
Camel stride. Okay. Okay.
And the third was with the Mecca pigeon.
Yeah. Do we have any questions for Hughes before we get into some discussion here?
Something that puzzles me is how can a mosque in the Far East, in China or in India, how can they get the right direction that far away using the triangulation technique? And
I'll add to that a piece of information. When the Nabateans, around the turn of the millennium, so we're talking about near the time of Christ, they went back to China with a Chinese explorer and appeared in the courts there. So the question I have is, if the people on that were going back, if they were counting steps, they might end up with a very long string to get them all the way over to China. But could they do it by keeping track of all of the measurements along the way? It's my first question. My second is, while they were in China, and I would imagine they were there for several months. I mean, you don't take a journey like that to turn around and come back. So they would have been there for a long period of time. They would have observed an eclipse. And the Chinese have records of all of their eclipse, even going back into 1,000 years BC. So they have a record of the eclipse, and many times of the time of day of the eclipse. So if they knew when the eclipse took place in China, and when they returned back home to Petra, and someone there said, no, the eclipse didn't take place at 4 in the afternoon, it took place at 9 in the morning, they would have a difference in time. Is that possible? I mean, I'm extrapolating, but I know both sides kept track of different eclipses, both solar and lunar.
I just, on that, you need an eclipse that can be seen both in China and in the Middle East. So it's not that easy. You know, remember that when they had to prove Einstein's theory, they had to go in Argentina to get, oh no, it was supposed to be in Argentina, and then it was in Africa, to get an eclipse. So you have to be at the right position at the right time. it's not, it could happen, but it's not simple.
Yeah.
Am
Okay,
I on?
you are.
Yes.
Okay. I want to suggest there is another issue with the eclipse, and that is if one of the locations during the eclipse has cloud cover, you've got a problem, right? I would like to suggest an alternative that happens more frequently, in fact, twice at least every month. If you take a face of a clock with an hour hand and a minute hand, put the hour hand vertical so you can use a plumb line for, say, the hour hand, put the center of the clock on the North Star, and then the minute hand can point to any other target star that you want. Okay? That gives you an exact time of night at your location. So there's like 3 scenarios we can work our way out, okay? I'm suggesting the day after new moon, you have a new moon. Very hard to tell when the new moon sets on the day of the new moon. But because it's about the moon averages about 13 degrees a day moving east. That means the day after you have 40, 50 minutes after sunset. And that's enough time for the stars to come out, even in Idaho with light pollution. So the point is, the day after new moon, everybody, and remember the ancients all used lunar calendars. So everybody was looking for the new moon, okay? So it would be very simple for every culture to keep track when the moon set the day after the new moon. Or later in the month, the moon rise of the new moon, or the moon rise of the full moon, or the full moon set. So you have options here. Now, all you need to do is have the timing, the angles of the stars, the target star versus the vertical, when the moon rises or sets at 2 locations on the same day. That's all that's required, because the east-west direction will be the difference in the angle of that target star. So you have a couple options. One, if you're fairly close, say you're a little bit east, you could use torches lights at night. So the eastern city lights a torch when its moon rises off the horizon, and then they relay it over to the western city. The western city waits until its moon rises. So it marks when the eastern city got its moon rise, and then it waits for its own moon rise, and you have that angle. I think you'd probably get it within 2 degrees, okay? You can do the same thing with pigeons over 1,000 miles. If you have the date, you say last night or the day before, the moon rose at this time, stating the target star or whatever, and then you can send the pigeon 1,000 miles over to Jerusalem or Petra or whatever. That's another scenario you can take. So I think that having multiple opportunities using moonrise, moonset during the month reduces the possibility of weather fouling up your equinox calculation. But it's the same calculation, if you see what I'm saying. So I think the ancients were able to do a longitudinal calculation. And I agree with you, getting angles at night is really tough, but I think they could have done it within 2 degrees.
Okay, that's very interesting. Anybody else with a comment or question? I just jump back to the one on the Mizpah that we mentioned. These are the beads that the Muslims count with, that they're used today to glorify God, is what the term means in Arabic. And so they count through. They have 33 beads, and I think they go through them 3 times to get their 99, which they use for the names of God. That was not in original Islam. We go back to one of the wives of Muhammad. Let me just see which one it was. I had it up here. Who is the first one who used it in Islam? Where is she? Yeah, Fatima. Fatima's the one, and she used it, used one as well, and that was that she put together. But before that, I mean, obviously they were known, but what were they used for before Islam? And they could have been used as a counting device. I don't know if the number 99 or 33 has any special advantage in working with navigation, but it was, if they're counting steps, they could also have been counting using the beads. And if you have a caravan, you're going to have the caravan master, and you're going to have several other people also, you know, counting along the way as well, just because they're all learning and becoming experienced. And even the old men who know how to do this without thinking, because they've done it so many times. So is there any thoughts on the Mizpah and this counting of using the beads? Do you think that would be helpful?
My theory would be that the beads would be used, or knots, for counting the number of poems that they had to do for each iteration. So if they had to do 50 iterations of a certain poem, keeping track of where you are in that iteration count would help you get through that.
Okay. Yeah, I think there could be lots of ways they could have used it. One of the things that struck me while we were doing this is that we, four of us, have been trying to figure out how they did it. But remember, all these people who were navigators and had learned this trade, they were trying to figure out how to improve it. And they were doing that over hundreds of years. So they had time to work out, you know, ways to make it better and ways to tie the knots in the string. We know they used knots in the string because that's what they used with this camel, the square block that they had. I need a square block that they would hold closer or farther away, and they would have a string with the knots in it. So we know that already knots in the string were being used to measure the stars. So that is a common thing as well. Any thoughts on that?
When you're using a sextant, you need to be very precise. Otherwise, you can miss an island.
Yeah.
And remember that I sent you a few emails that some islands in the Pacific, which were mapped by the French, you have mentioned that, let's say, could be 7 or 9 miles more west or more east. That's just because they were not able to measure time precisely, and it was before the invention of the chronometer. So and they were observing the moons of Jupiter to measure the time. So I believe that the guy was not very good. So 7 miles means that they made almost 30 seconds, half a minute of error. That's not a lot.
What?
But it's 7 miles, and you can. So, and even when you're using a sextant, you try to avoid using a planet because it's not precise enough. You try to avoid using the moon because it's not precise enough. So you prefer to use stars because it's a point, and this is precise. And even if you are a good observer, very good observer on a calm sea and having a precision better than a mile with a good chronometer, a better precision than a mile with a sextant, it's pretty hard. It needs experience. So it's not simple. In a sextant, you have lenses. You have a vernier to to be very precise. Maybe for people who don't know what a sextant is, I just get a plastic sextant.
So Mark, you've used these.
I have used sextants, although on the aircraft it's a periscope sextant.
Okay.
Yeah, it's a periscope. So this is a very simple sextant. You know, it's so and on this one it's for you know, it's not professional, but I'm using it when I teach how to use a sextant. So you don't have a lens. The precision is okay, but when you need a better precision, it's not the kind of tool you will use. But if you need a precision of a few miles, it's okay.
So the larger the instrument, the more precise you can be?
If you use an astrolabe, you will make it big, huge, so that you can have a good definition of the angle.
Okay, so this is why you were suggesting they drew this out and set up something that's bigger.
Absolutely.
Now, I noticed in reading through some of the navigators, the Arab navigators, they had a whole discussion on the North Star, because the North Star is not fixed in the sky. It actually moves a little bit, and there was a whole discussion on when you take this in the height and where it is in the movement of the North Star in the sky. So they were interested in precision, if they were that interested in the North Star and its movements.
Yeah, but it's the precision. I mean, it's 1 degree. I just in my slide. I will go back to my slide. So,
but the farther the distance, the more 1 degree is important.
No, because 1 degree. 1 degree is 60 minutes. 60 minutes is 60 miles of difference.
Right.
60 miles is, you know, it's a lot.
But that may explain why some of the Qiblas of some of the mosques were out by actually several hundred miles, you know, from the point, because it was supposed to be here, it was over here.
Let me go back to
this instrument. Okay.
So the polar star declination is 89 degrees and 15 minutes. It's the declination. So it means that it's off the pole by 44 minutes. And it changes, of course. This is recently was taken on Wikipedia. But of course, you have the precision of the Earth. Everything is moving. It's not very fixed.
Right.
So it's why, you know, the ephemeris are published every year.
I know when I was doing the Qiblas in that timetable, the man doing it was a mathematician, and he wanted to work out the equinoxes back in a certain date because they had moved over time. And so, I mean, we picked 800 as just we'll just pick 800 AD and what were they at that point, because the majority of mosques were built between 700 and 800 AD, so back in there. So we had to just sort of pick a point. But as you said, everything is moving a little bit. And so accuracy because I get people coming saying, oh, but it's out by 0.33 degrees accuracy. And I'm like, I don't think that they could establish that accurate, especially navigators with their camels. However, once they built a mosque, I mean, they were going to build a mosque. You're going to put a lot of effort in. Some of these had 500 men working on the construction. So they could easily make sure that they had somebody there who was going to orient it correctly and could build a larger instrument to measure and try to get his Qibla direct. Okay, any more questions? Comments? I've really enjoyed this. We've had a lot of fun. And I want to just thank you guys, each of you. It's been a little work to try to get you together. Some over in Paris, and in America. I'm up in Canada, so we had to sort of pull this all together. Thank you very much for doing this and allowing our viewers to be able to listen in to a discussion of how the Qibla might have been set and could accuracy be attained. So thank you very much, and I'll say goodbye to all of you now. So bye-bye.
Thank you for letting me be a part of this.
You're welcome. Okay, that's the end.
It was a great pleasure.